Good morning, everyone. Good morning, everyone. I hope all of you can hear me. Okay, so this is where we stopped yesterday. We derived the magnitude for the resultant. We derived the magnitude for the resultant of two vectors A and B, right? Okay. So even yesterday I told you about that warning regarding angle. So let's talk about that. Let's practice this formula. Okay, how to use it. All right. So you see, suppose two vectors are given to you, right? Let's say, okay, we're just solving one question. We're just solving one question related to this, right? Okay. So let's say that if A vector and B vector have magnitudes, let's say 3 and 4 respectively, okay, and the angle between them is for example 60 degrees, right? Okay, find the magnitude of their resultant. Again, resultant means R vector, okay. Clear? So we have to find the magnitude of their resultant. Resultant R vector, that is nothing but this. Okay. So you see, what we have derived here is that if you are given two vectors, A vector and B vector, if you are given two vectors, A vector and B vector, and if you know their magnitudes and you know the angle between them, then you can find the magnitude of their resultant, that is of this, right, of addition of the two, right? So let's draw it first. As usual, I'd like all of you to draw it. Okay, so suppose this is A vector with, let's say, magnitude 3, and let's say here is B vector, right, with magnitude 4. Okay, and what's the angle between these two? It is 60 degrees. So in this case, if you want to find the resultant, and its magnitude, so of course the parallelogram law says that the resultant will be like this. All right, so this is the resultant. But what's the magnitude of the resultant? If you want to find that, we can use the formula. Okay, so please do that. Come on, let's see what answer you get. Hurry up, come on. Everyone, I'm waiting for your answer. Please hurry up. I'm giving you 1 minute. Okay. Some of you are saying 5. અરે યાર કેમ આવું કરો છો? 5 ક્યાંથી આવતું હતું હે? ગોખેલું હોય એ બધું ભૂલી જાવ હવે. No way, forum, it cannot be 7. You cannot add magnitudes, everyone. Yes, so some of you are saying root 37. Let's check. Okay, so this is going to be a square plus b square plus 2ab cos theta, right? So let's put values. A, its magnitude is 3, b, its magnitude is 4, and cos theta is angle between A and B, so 60 degrees. So you just have to put all these values. All right, that's it. So simple. 25 plus 9 plus 16 is 25. Over here, cos 60 is 1 by 2. I don't think anyone has any problem with that, right? So this 2 is cancelled with this 2. So the answer is going to be root of 37, right? By doing addition. Okay. So many of you got it right. This is the correct answer. Root of 37. All right. Please do not use calculator unnecessarily. એકદમ સિમ્પલ હતું. રૂટ 37 આવે. 33.9 ક્યાંથી લઈ આવ્યા ખબર નહીં. People, a word of warning. You have been taught the table for sine, cos, tan, everything. Yes or no? I hope all of you remember these things. Okay? આ બધા આવડવા જોઈએ. 0, 30, 45, 60 and 90. જેને આ નહીં આવડે એ ફિઝિક્સમાં પાસ થવાનું બહુ અઘરું છે. લેટ મી ટેલ યુ દેટ anybody who does not know all these values by heart is very likely to fail in physics. Clear? So please beware. આ આવડતું ન હોય તો આજે જ ગમે તેમ કરીને કરી નાખો અને એવું કરી નાખો કે લાઈફ ટાઈમ ભૂલાય નહીં. ઓકે everyone, I can see some of you gave wrong answer to this question because you didn't know the value of cos 60 degree. ઘણાએ √3/2 લખ્યું જ હશે. I'm absolutely sure about that. Okay, so please be careful with it. Okay, nevertheless, so this is how you use this formula. All right, this is how you use the formula. Okay, અને અલગ અલગ ઘણા ફોર્મ્સમાં કરી શકાય, right? Okay, but that is for practice. Yeah, okay, now find magnitude of resultant of the vectors C and D as shown in figure. Okay, so suppose here there is a figure, right? Okay, let's say this is C vector which is having magnitude 12, right? And suppose here is D vector, let's say, which has a magnitude of maybe what, 16. All right, let's say this is D vector with magnitude 60, and if this angle is given to be let's say 120 degrees. Okay, if this angle is 120 degrees. So I'm giving you this question specifically so that you will understand this warning. Okay, where's the warning? Well, was it here? No, it was here on this page. Here, this warning, right? I hope all of you remember what I told you. It's that whenever you want to measure the angle between two vectors, it can only be done by joining their tails, right? So if you would read this, and if you go to this question, you can clearly see that theta, that is angle between two vectors, here angle between C vector and D vector, is not 120 degrees. Is that clear? Is that clear? दिखावे पे मत जाओ, अपनी अकल लगाओ. Okay, that is what is applicable here if you think about it. The diagram shows 120 degrees. That is to confuse you, that is to test your concepts. આવી રીતે angle measure no થાય. So what we have to do is, listen to this carefully, we have to drag this vector along this line. I hope you remember that you can always shift vectors but not rotate vectors. I hope all of you remember that. Okay, so what you'll have to do is, you'll have to pick this vector C. આ મારા માટે બહુ easy છે, અહીંયા કોમ્પ્યુટરમાં કરું, but I'm sure you will also understand, right? You can easily do it in your notebook as well. Okay, so we pick this up and અહીં મૂકી દેવાનું. Understood? So if you do that, how many of you understood that this angle is going to be 60 degrees? How many of you understood that? How many of you understood that this angle is 60 degrees? Right? This is clearly because of supplementary angles. If you draw one dotted line, if this is 120, remaining should be 60, correct? Okay. Yes, that's why 180 minus 120 is 60. Okay, so now solve this problem. Come on. Now solve this problem, everybody. Okay, do it, everyone. Find the magnitude of resultant. Find the magnitude of resultant. Okay, come on. Hurry up. Are you sure, Falak? The answer is exactly what you are writing. Okay. Yeah, you can shift D vector also, doesn't matter, right? You can shift D vector also, but Falak, your answer is wrong. Yes, angle will remain the same. Okay, we are getting lots of answers. Okay, let's check. So R is equal to, the magnitude of resultant is equal to a square plus b square plus 2ab cos 60. Okay, here it's going to be 60 because theta is 60, right? Okay, but actually it's not a here, it's c and d. Just a minute, it's not a here, it's c and d. Doesn't matter, formula તો આપણે લખવાની છે, right? Now we will put values. Okay, we know that these are two vectors, so instead of a it is c, instead of b it is d, so you can just write it like this. Clear? Okay, so that's, I don't think anyone has a problem with that, right? So now this is going to be equal to under root 12 square plus 16 square plus 2 into 12 into 16 into cos 60 is 1 by 2 once again, right? So based on that, we are getting this to be under root 144 under root 256, 2 cancelled, and 12 into 16 is 192, right? So this total is 4 plus 6 10, and carry 2, carry 1 10, and 5 15, and 4 19, carry 1. So 1 plus 1 2 plus 2 4 plus 1 5, root of 592. All right. Yeah, so root 592 is primarily the answer, but then I'm sure you realize that this is 37 into 16, right? This is 37 into 16, isn't it? How do I know 16 into 3 or 30 is 480, and 16 into 7 is 192? Oh, sorry, 130, excuse me, 112, excuse me. Yeah, right? 16 into 7 is, so if you add them, you get 592. So that's why this is root of 16 into root of 37. So that is 4 root 37. Clear? Sixteen into 12 તો મેં કર્યું actually, Nandini, right? But it was very fast, I agree. 16 into 12 મને યાદ નથી, but I did it like this. 16 into 10 is 160, અને પછી 32, right? Because this is 16 into 2, એટલે 192, right? Okay. It's all about practice, people. I'm not using any kind of special techniques, right? In fact, if you remember, I've told you earlier that my calculations are actually quite poor, right? Speed છે, agreed. My calculation is fast. But it is not accurate, if you understand what I'm saying, right? I get it wrong often. Okay. All right then. Right, so this is it. Okay, now let's go to a relevant or related thing. Okay, let's go to related thing, right? So I'll just copy that diagram which I drawn earlier. Okay, I want this diagram, right? So okay, time for you to, okay, I'm so sorry. There was some error, right? This program just crashed. Okay, connection is still on. Don't worry. We are just going to start in one fraction of a second. Just a moment. Okay, now I'm sure you all can see the screen. Okay. So I was just copying this diagram actually. Right? We just need to use it again. Uh, every time I copy this diagram, this crashes. I don't know why. Okay, let me just do it again. Okay, perhaps it wants me to draw it one more time. Okay, I don't mind. I'm lazy, but I don't want it to crash again. Okay. Okay, let's go to a new page and let's redraw the diagram. જો એ કેટલી વાર લાગે. Oh, this is too thin for you. Okay, now this is better. All right. A vector, B vector, and R vector by using parallelogram law. જોયું આવી પ્રેક્ટિસ હોય ને એટલે ફટાફટ થઈ જાય, બાકી કંઈ નથી હોતું, right? Everything becomes easier eventually with practice. Wait, sorry, this is not theta, this is theta. Right, so this is what we have. Okay, so now this time we are going to talk about something interesting, the angle, this angle. Okay, so do you think that suppose this theta, suppose A vector and B vector would be like this, let's say this is 60 degrees suppose, then what do you think will be the angle between R vector and A vector? What do you think will be the angle between R vector and A vector? What do you think will be the angle between R vector and A vector? કોણ છે ભાઈ આગળ આગળ જતા આલ્ફા કહેવા વાળા? બુકમાંથી જોઈને લખો છો કે ટ્યુશનમાં ભણાવ્યું છે? તો બરાબર આવડવું જોઈએ. ટ્યુશનમાં ભણાવ્યું હોય તો, નહીતર હું તમારા ટ્યુશન ટીચરને કમ્પ્લેન કરી દઈશ. અને બુકમાંથી જોઈને લખતા હોય તો વાંધો નહીં, તો પછી બે બાજુ ધ્યાન રાખજો. Okay, so many of you are saying it's 30 degrees, and I get your sentiment. I think you are saying that okay, this should be exactly in between, right? I think that's what you are thinking, that this should be exactly in between. Well, it's not like that. Okay, it's not like that. Yeah, you have this sentiment, you have this feeling from inside, right? કોઈએ તમને કીધું નથી, nobody proved it also. You got this feeling from inside, right? Okay, so well, it's not true. Let me make all of you recall a property of parallelogram that your teachers in 10th or 9th would have tried hard to explain. Here is the property. It's that if you draw a parallelogram, and you draw a diagonal, આવડે ને diagonal draw કર, આ diagonal જ છે, then is it necessary that these angles are equal? Are you sure that these angles are equal? Equal થાય ને, in fact, if these angles are equal, suppose these two angles are actually equal, then this would become a rhombus. I hope You realize that? ના તોય ન થાય actually. Rhombus માં ન થાય કદાચ. It happens only in a square or a rectangle. I'll have to do some basic geometry course once again, right? After this class is over, I'm going to sit with my paper and pen and I will derive all the properties again. ઘણા ટાઈમથી યુઝ નથી કરી. Anyways, coming back to the point, it's not necessary that these angles are equal. એટલે તમે જે કહો છો કે આ 30 હોય ને આ 30 હોય, that's not going to happen always, right? Okay, what I'm saying is it's not necessary that this is 30 and this is 30. So it might be something else. Let's derive it. How much, what will that angle be? So let's say this is alpha. Okay, Jairaj, let's say this is alpha, right? So now do you see the triangle? Okay, no problem. So if we take this large triangle, હવે મેં ત્યારે શું label આપ્યું હતું, I don't remember. I'll have to go back and check it. Can I get your diagram? Here. Okay, L and P. Okay, L and P. Right. So if you look at L and P, all right, look at the triangle L and P. In triangle LNP, tan alpha is equal to NP upon LP. Okay, so NP is equal to B sin theta divided by LP. Is this clear, everyone? I'm waiting for your yes or no. Tan alpha is opposite upon adjacent. So opposite upon adjacent. અને પછી values મૂકી દીધી એટલે થઈ ગયું. Okay. So this is also an important formula, everyone. This is also an important formula. So if you want to summarize, this whole thing, okay, if you want to summarize this whole topic that we have been talking about, then here are the 2 points. Okay, if r vector is equal to a vector plus b vector, then number 1, r is equal to a square plus b square plus 2ab cos theta under a big square root. Okay, all right. Then second one, angle between r vector and a vector. See the diagram, everyone. This alpha is angle between r vector and a vector. I hope you all understood what I'm drawing, right? This alpha is the angle between r vector and a vector. So angle between r vector and a vector is given by, or is found using, okay, tan alpha is equal to b sin theta upon a plus b cos theta, right? Okay, now below, wherever you are writing this in your notes, I recommend that you draw the diagram here, okay, over here with the formula. કારણ કે ખાલી formula ગોખીને કઈ મતલબ નથી, પછી તમે ભૂલી જશો કે આ બધું શું હતું. So draw the diagram along with it, and below this write the terms. Okay, terms means what is everything. Okay, right? So what is everything? R means what? Magnitude of resultant. Okay, this is actually very simple. A means magnitude of vector A. આવું બધું આવડવું જોઈએ આમ તો, પણ તોય તે this is for people who don't want to remember any basics. બરાબર? You can skip these three. I think these three are optional. બરાબર ને? મેગ્નિટ્યુડ કે લખાય ખબર હોય તો આવડે. થીટા is angle angle between A vector and B vector. Okay, બસ આટલું લખી નાખો એટલે આ બરાબર યાદ રહી જાય. And this is very 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 important. Again, we use this often in 11th and in 12th. Okay, right. Scroll up. તો આ નીચેનું વયું જશે. ચલો. Okay, this is it, right? That's it. Now we are not going to okay. Now let's go to the next thing. By the way, just to clarify, whatever we have done here was example 4.2. આખું જે કર્યું ને એ example 4.2 છે. Okay, right? I took it as a derivation, right? I took the whole thing as a derivation because it's very important to remember this formula. Now the next point. If D vector means difference is equal to A vector minus B vector, then okay, then D is equal to under root A square plus B square minus 2AB cos theta, right? આ કેવી રીતે આવે? Prove it yourselves. Okay, clear? And if you prove it, please send me the proof. Okay, please derive it or prove it and send me the proof. I'll just draw a diagram to give you hint. Okay, here's the diagram to give you hint. તમારે કરવો હોય તો ડ્રો કરતા જાઓ, પછી આગળ હું કંઈ નહીં કરાવું. Okay, so this is A vector, B vector, and this is angle theta between them. Now if you want to find difference vector, I hope everyone remembers the triangle law of subtraction. Okay, I hope everyone remembers the triangle law of subtraction. So અહીંથી આમ આવશે. I hope this is clear. And then you just drop a perpendicular and પછી આગળ calculation જાતે કરવાનું. Okay, from here you are on your own. Okay, I have drawn a diagram for you. We want to find what is this length, magnitude, right? From here on you are on your own. Yes, send it to me on WhatsApp, okay, on my number. All right, don't send it to school, otherwise you will not get a reply from me. Please, when you send, please send it with your name so I know who is sending me this solution. Okay, Dia, can alternate angles be equal? Yes, if parallel lines are there, alternate angles are equal, right? Dia, whatever you have learned in 9th, 10th, that is still true, right? It didn't become wrong because of coronavirus, right? Okay, right. So this is also important formula, everyone. This is important formula, right? I want all of you to remember this as well. Okay, right. Now let's go to the next thing. ચલો એક ક્વેશ્ચન આપું મસ્ત. Okay, so now we are going to do it, right? I'm giving you 1 minute to think about it. Okay, frankly I'm tired today, I'm not feeling very well, right? Just by teaching 35 minutes I'm feeling very tired. So I'm going to rest for a minute and you think about it, okay, and you send me what are your ideas, or if you get the answer. Come on. Okay, Divya, I hope you have solved it. Okay, very good then. Yes, Jaikit, that is right. Yes, Raj, correct. Forum, you can't guess. I hope you have the solution. Yes, Palak, your proof is perfect. Okay, that's how it will be. Okay, a lot of people have got the answer. Let me just tell you the answer. The answer is that theta equal to 90 degrees. Okay, theta is equal to 90 degrees. And why is it so? Let's solve it. Okay, let's solve. જો પ્રૂફ વગરનો આન્સર નકામો, બધાને કહું છું, રાઈટ? પ્રૂફ વગરનો આન્સર નકામો. ઇફ યુ ગેસ્ડ ઇટ, it's not going to be of any use in exam. બરાબર? So make sure you do it, right? So here we go. First of all, we will use the formula for this. તો આની ફોર્મ્યુલા શું છે? It is under root a square plus b square plus 2ab cos theta. Now we'll use formula for this. So that is equal to under root a square plus b square minus 2ab cos theta. All right. Now square both sides. Okay, square both sides. So if you square both sides, you get a square plus b square plus 2ab cos theta equal to a square plus b square minus 2ab cos theta. So now everything else is cancelled and you are going to get cos theta equal to 0, right? Okay. So you get theta equal to 90 degrees or pi by 2 for math students. Okay. So that is the correct answer, right? That is the correct answer. Okay. Now I think that's enough practice for this type. Okay, so I mean I try to give some more in homework, all right? કારણ કે ઘણું હજી તો કરવું પડશે. I know Okay, so now the next topic is finally physics. Okay, next topic is finally physics, right? Okay, right, all the maths is over now. So you see that when uh, when I'm saying that physics is starting, now we are going to talk about motion in a plane, right? Okay, officially. See, if you remember when we started the chapter motion in straight line, if you remember when we started the chapter motion in straight line, that is the previous chapter, the first thing that I taught you about was that always there has to be a frame of reference. Do you remember that? There has to be a frame of reference. So that is still true here, right? Okay, so you are going to specify directions as positive, negative, right? You're going to specify origin, right? You're going to specify origin, right? Okay, so then you're going to specify, you're also going to specify the clock, that is when does time t equal to 0 occur, right? And all that. Okay, so I hope you remember that frame of reference is based on these three things. But here you see the directions is a little bit interesting, because here we are talking about plane, so there are two axes, right? There are two axes, which two? X and y. Okay, so listen to this very carefully. I can choose anything as origin. I hope you remember that frame of reference depends on observer, right? Observer says, okay, I want to observe like this from here with this direction positive and this direction negative, then you have to allow, right? You can't say, no, you can't observe it like this, right? Okay. So again, frame of reference is observer's choice. Please remember that. Okay. So all these three, they are observer's choice. But yes, there is one rule. X-axis and y-axis have to be perpendicular to each other. એવું પછી cheating ન ચાલે. What I mean to say is observer એમ કે મારે તો x આમ લેવું છે અને y આમ લેવું છે. That is nonsense. આવું નહીં ચાલે. Is that clear? X and y axis should be perpendicular to each other. Got it? Okay. So if you are talking about 3D, suppose motion in space, space એટલે 3D, right? Plane એટલે 2D અને line એટલે 1D. Okay. So if you talk about space, then there will be three axes. So then it should be like this: x perpendicular to y, perpendicular to z. Okay. આવી રીતે જ હોવું જોઈએ. ક્લિયર? હજી બહુ આગળ મેથ્સ ભણશો ને પછી એવું આવશે કે આવું કઈ જરૂરી ન હોય. બટ હિયર આઈ થિંક વી શુડ બી વિધિન અવર લેવલ, રાઈટ? ખોટું પછી 5 વર્ષ પછીનું મેથ્સ નું બહુ 5 વર્ષ પછીના મેથ્સની બહુ ચિંતા ન કરો. ઓકે, just understand that right now we should have axes perpendicular to each other. Okay, ગમે તે હોય, 2 હોય તો 2, 3 હોય તો 3, doesn't matter, right? Axes should be perpendicular to each other. Okay, now again to remind everybody, what is position? I hope you remember that position is actually a vector. Do you remember that? Position is a vector and its symbol is this. Okay, all right, yes. So now if you realize, listen to this carefully everyone, if you realize that suppose these are the axes, right? Suppose these are the axes and you take position of some particle or some terrorist as usual, right? Let's say here's the terrorist. Okay, and suppose this terrorist is at position 3,4 meter. all right, and that's what we have reported. So do you agree that the position vector should be drawn from origin to this point? Clear? Is this clear? આટલું તો યાદ હતું ને કે ભૂલી ગયા છો? જ્યાંથી આવ્યા હતા ત્યાં પાછા ચાલુ કર્યું હવે, right? But now we are armed with all the maths, right? Okay, now we are armed with all the mathematics. કેટલું બધું મેથ શીખવાડ્યું, ચાલુ મેં આમ જ કર્યું હતું. Falak is saying, wasn't he caught already? He was only taught, he was not caught, right? So do you understand that this distance is 3 and this is 4? How many of you understood this? Say yes or no. How many of you understood this? Okay, this is clear-cut case of components, isn't it? This is clear-cut case of components, right? This is the x component 3 and this is the y component 4. Okay. Now, I hope this is as natural as Patanjali's products. Okay. That was just a joke. Don't take it seriously. It's not natural, Rohan. This side is 3 and this side is 4. So if I split it, I hope you realize that I can make one vector like this. I can make one vector like this here. This is 3i caret vector, correct? And I can make one vector like this. This is 4j caret vector. So થઈ ગયું ને, by triangle law of addition, r vector equal to 3i caret plus 4j caret. Right? Okay. Now, so in general, do you agree that suppose if it was like this, suppose there was this terrorist guy at position x comma y, okay, suppose the terrorist was at x comma y and this is the position vector, then do you agree with this? Do you agree with this? All right, Rohan, then that is right. I was also saying the same. Okay, so now if someone asks you, how do you write position vector? Then you say position vector is always r vector equal to xi caret plus yj caret. Suppose you write it in 3D. Okay, 3D means motion in space. એ હાજો એની પછી યાદ આવ્યું, મારે તમને ઓલું જીઓ જેબ્રામાં દેખાડવાનું હતું, મેં તો બનાવ્યું જ નથી. I totally forgot it. I'm so sorry. Yes, I totally forgot that. I will definitely do it. Okay, if I'm feeling well. Actually, I'm not feeling very well right now. It seems like I should just stop this lecture and rest. Okay, so this is in 3D. All right, now, okay, now let's talk about displacement. પાછું displacement, third chapter માં displacement આવી આવતું હતું. Agreed? Or maybe x2 minus x1, right? Okay, now 10 minutes are only left. We will finish it. All right, no problem. એટલું તો હું ખેંચી લઈશ હવે. No problem. તમારો લેક્ચર તો થઈ જશે, 12th વાળાનો જશે. કોણ બોલ્યું ડિસ્પ્લેસમેન્ટની કેટલી ફોર્મ્યુલા છે? નંદિની, અરે see, Nandini, in different situations, we need different things, right? So this is applicable for 1D, correct? Now for 2D. Right? Okay, we have to write it like this. So this is equal to, see, you can also write R2 vector minus R1 vector. Okay, I don't mind. હું તો આમ જ લખવાનું છું, right? So this is going to be x2 I caret plus y2 j caret. This is whose value? This is the value of R2 vector minus, I hope this is clear, right? Okay. And now I have already taught you how to subtract. યાદ છે ને? I have already taught you how to subtract. So this is going to be it, right? Okay. You are saying you don't have a problem, right? But when we started this class, there were 90. Right now there are 83. So perhaps many of them have sensed, or they are getting the same feeling that I am not well, so they could not attend the class, right? Very interesting, isn't it? I am not well, so they could not finish the whole class. So now, do you agree that this is equal to this? This step is very interesting in my view. Health is important, right? Perhaps they were thinking that sir has been infected with coronavirus and it might be transmitted through online lecture. Okay. Is this clear, everyone? Okay, jokes apart now. I think that's enough of jokes. Is this clear? Okay. So now what we are getting is an interesting thing here. Have a look. We are getting that the displacement vector, we are getting that the displacement vector in 2D is actually made up of two displacement vectors. This is displacement vector in X and this is displacement vector in Y. Yes, all right. Agreed? And suppose it was in 3D, then you'd get a third one also, right? If it would be in 3D, then we'd get a third one also, right? Like this. Okay. So this is what makes me write this very important and very helpful line. Here it is. Motion in 2 dimension can be thought of as, or can be considered, okay, right? Language અઘરી લાગે તો કહેજો. Motion in 2D can be thought of or considered of as two separate motions, two separate or two independent motion, two separate or two independent motions, all right, one in x direction and the other in y direction. Did you understand this sentence? You heard that? That was interesting. I said that here you see this displacement vector is actually made up of two displacement vectors, right? Okay, this is displacement vector in x axis and the other one is displacement vector in y axis. So what I'm saying is that we can consider that this motion, right? Suppose you consider the motion of a person. Let me explain with an example. I think that will be easier, right? Let me explain it with an example. Okay? Right. So let's say this is x and y axis. Right? So suppose this person from here goes to this point. Right now, let's keep it simple. Let's say this person moves in straight line. Okay. So do you agree that this will be the displacement vector if the person moves from point A to point B, right? If the person moves from point A to point B, this will be the displacement vector, right? Okay. So do you understand that this displacement is little bit towards left side and it is also upwards? Yes or no? Right? So what you can actually say is, suppose you draw a rectangle, okay, like we have been drawing earlier. So do you understand that this is the x component here? Okay, let me use another color. It might be clear to you, right? It would be easier to see. So let's say this is delta x, agreed? Right? Because that is on the x direction or on the x axis or parallel to x axis. Clear? And this one is delta y. So what I'm saying is you can consider that this person shifted in two different directions, one left side and one upwards, and these two, they are separate from each other. That is, the left side and the upward motion, they are separate or independent of each other. So it's like, suppose this person moves 5 meter left side, okay, and 12 meter upward. So these two are two separate things. So I can actually write the whole as follows. We can say that the motion or the displacement is a combination. You understand what is meaning of a combination, right? The displacement is a combination of two things. Which two things? Moving 5 meter left and moving 12 meter up. That is what I'm trying to explain. Yes, they are independent but happened simultaneously. Agreed, Falak. Right? The motions happen together. Right? But they are independent. એટલે એવું નથી કે delta x છે એટલે delta y છે. I hope you understand that there is no cause kind of thing here. Right? There is no reason. આવું હોઈ શકે ને. See, why am I saying they are independent? It is also possible that instead of going like this, the person can go like this also, just a minute, like this. So in that case, we'll have to redraw the rectangle. But do you see, delta y will still be the same, only that delta x is now smaller. You understood what I'm saying? Right? Delta y will still be the same, but delta x will be less. Yes, Nandini, exactly. Parallel to y, so delta y, parallel to x, so delta x, right? Okay. So you see, it's not necessary that if this is 12, this should be 5. That's why they are independent. It is also possible that this is 3 meter and this is 12 meter, right? That is, there is no direct connection or link between them. Okay, there is no direct link between them. Okay, Vedant, you're asking, can we write north and everything? No, I'd say now that we have learned all this, it is, unless it is given in question, please always write I caret j caret. Okay, unless it is given in question. Yes, એવું y axis પર એ થઈ શકે, right? Unless it is given in question, we will write I caret and j caret. Okay, yeah, generally we answer in standard form generally. Okay, પછી ક્વેશ્ચનમાં એવું કીધું હોય કે આન્સર લાઈક ધીસ, તો આપણે કંઈ ન કરી શકીએ, right? Okay, with that let's end this class. All right, okay, goodbye everyone. Yeah, we will derive properties of parallelogram later. All right. Yes, Nandini, do you want to say anything? Can you please send me a message on my phone? All right. Yeah, hopefully I will get well soon. Thank you so much, everyone. Thank you so much, everyone.